let me get started. You can ignore all this. I just had some old files lying around. Okay, I want a new project. Uh, just yeah, seems fine like this.
Yo, man.
Hello.
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 More.
It's getting
More.
crowded. Sure, you know there would be 50 people thinking you're giving another lecture again.
Well, I mean, I don't expect it to be anywhere near as big as like the previous one because it's not like any assembly help or whatever. But yeah. So let me map it out first. It's gonna have a few important components. We have a computer, like fuck it. Let me Google that shit. How do you get von Neumann architecture? That's what we're most likely gonna be using. So we've got like memory, a CPU, and I/O. We're first gonna focus on the CPU and memory. So I'm gonna make a new class called CPU, and I'm gonna add a main function to it. Is there like, what was it?
Where your autocomplete doesn't work.
Hmm?
Where your autocomplete doesn't work.
Yeah. I'm also gonna add a memory class, which I'm gonna that's gonna be mostly for later. And yeah, that should be it. Okay, so I'm gonna add a few things. I'm gonna make everything public because I'm the only one who's gonna be using it, so I don't really have a reason to make it private. Because usually, like the reason for yeah, whatever. I'm just gonna have my memory, which let's see, what are we gonna make our memory?
Big.
It's probably gonna be
Huge.
hmm.
Is this the cache memory or the RAM?
What did you say? Sorry.
Is this the cache memory or the RAM?
Oh yeah, this is gonna be the RAM. So
Does
I'm
the
gonna
RAM
probably make
just
that an
not
array
use-
of. I think I could
RAM
just
is
use a
not-
byte array.
Nice.
I'll make it hex 1000. Oh, you cannot do that for real? Fucking.
You need
That's
to
a
do
little
its
bit.
new byte.
You
Hmm?
have to create a new byte first before I can do that.
Its new bytes 100
Ah, I see.
or 1000, I don't know.
I didn't do like any of the assignments with arrays yet. I didn't do like much of anything yet. I'm just completely spitballing everything as I go. I
you
understand like the
can-
concept that I'm gonna be implementing, but how I'm gonna be implementing them is gonna be a mystery.
You can just initialize the memory in the same line.
Yeah, in the constructor, you mean, right?
No, also in the
Yeah,
same
or
line.
just in line with your variable.
Oh, really? Cool. Okay, so we have memory.
But wouldn't
We can have-
it make more sense to make put memory in the motherboard, not the CPU class?
Well, I guess, but I guess instead of a CPU class, it should technically be like the a computer class then, because everything's gonna like come together here.
Yeah.
Yeah, I guess. That's actually a valid point. I'll
should
make a
probably
new
have that.
class called computer. But at the same time, then I'm gonna have to include my CPU class to the computer, and I really cannot be asked to do that. So I'm probably just gonna keep it like this. But like this is gonna be the class where everything comes together. So we're gonna have our memory. We can have our memory mapped I/O, our registers are all gonna be in there. So let's see. For registers, I can either make a separate thing for every register, but I'm probably just gonna make another array of bytes. Okay. And then let me add some comments. Is Java a comment like this? Yeah.
Yeah.
The memory, of course, yeah, there's nothing really too special about that, but the registers, they're gonna be in order. So we're gonna have to think of some registers. Woo! Um,
Are you also going to do floating point operations?
no, by God, no. This is gonna be like the most basic of the basic. I'm hoping that I can get
Well-
like some basic instructions like move literal and stuff like that, and maybe adding or maybe multiplying. But yeah, that we'll see how far I'll come. But we gotta make
Well,
some registers.
we
We
need
gotta
a
also
stack
decide how
pointer.
big are. Mhm.
You need a stack pointer.
Yeah, but the stack pointer and the base pointer and the instructions pointer are all registers themselves.
Yeah.
So everything we really need are just the memory and the registers for now. But we need to think of which registers we're gonna need and how big our registers are gonna be. So I'm probably gonna stick with 32-bit registers. So I might. I can do this two ways. I can say it'll be an array of like 4-byte rows, or I can say it'll be an array of uint32. Can I do that in Java? There's so many
I
talk,
don't
but it's
think
really
there's
soft.
unsigned ints in Java. Not like that anyway.
Okay, all right. Now I'll just make it an array of an array of bytes. But that means we can have like an array of 4 bytes, 4-byte register. So we'll have like, for example, let's say we have like 5 registers. That would be like this, and then every register would have its own like sub-array. But we'll have to think of like an order for them. So we're gonna have probably like RAX, or in this case it would be EAX since we're gonna be using 32-bit registers. That would be the first one. EBX, ECX, EDX, EDI, ESI, and then the instruction pointer, the stack pointer, and the base pointer. Like there are more registers in the like Intel version, but I'm probably just gonna keep it at this. And like if we need more, then I'll just add more later. That's no big deal. Okay. Alright then, let me generate a constructor real quick. It doesn't take any of these. How can I select none? Whatever.
Like that.
Hey, foreign like you. Okay, so I can say memory, and then a size, which is, let's give it like 1,000 bytes of memory, which is way more than we're ever gonna use. And is there like a way to fill it? Public static void.
Pretty sure you just have to loop over the entire array.
Yeah, we can do that real quick.
Isn't it already 0 initialized?
Oh, if it is, that is gonna be sick.
I don't think it is.
Let me put this in the proper way. I'm struggling a bit with Java syntax, as you can tell, but that's like just because I'm so used to Python.
The byte doesn't work the way.
Hmm?
You already initialized, you already declared byte there above, so you need to just do memory is new byte 0x100,000.
Ah, all right, sick. We're getting somewhere,
We are
guys.
now teaching the teacher.
Yeah, no, I am like this is not supposed to be a lecture, but more so just like a little project we're all just doing together. If it was a lecture, I would have actually prepared something, but I didn't. I'm just spitballing everything.
We are the lecturers here.
Yes.
Mutiny.
Viva la revolution! Okay, no, but we have a new area, a new array of bytes, and if this is 0 initialized, that's gonna be great. And then we have like registers is new byte. So then we're gonna have 1, 2, 3, 4, 5, 6, 7, 8, 9 arrays of 4 bytes. Okay, so this is going to give us enough space to address each of our registers, each of our 9 registers in this case individually. However, I am not going to do anything with the stack probably now. And enough to store 256 or hex FF bytes or hex FF words. There's like some complex terminology here, like words 4 bytes, or is that true, or is it long word? Shit sucks.
No.
Is there no lecture today?
There is a lecture for assembly today, so if you want to attend that, or for assembly for CO today, if you want to attend that, please go there. This is just something I'm doing as like a little hobby project, and it's nothing like, it's not about assembly, it's not about anything interesting, it's just a little fun project I want to do with you guys.
A word is 2 bytes. I have to remember that for the rest of my life now.
Okay, a word is 2 bytes. How much is 4 bytes? Is that like a long word?
Yeah, long word.
Or double
Or
word.
quad
A
byte.
double word. That's the word I was looking for. Thank you.
Also
Okay.
double long.
So we got the registers, and let's start with a. I need a way to define all my instructions. So let's say I need to have add, or let's make a real basic instruction. Move literal to memory. I need the way to say that this is 0x00, for example. I guess I should then just do public byte. Yeah, I think this will work. And this is how we're going to be describing our ISA. If you didn't watch the lectures, you need to watch for this week. Then it's going to be already running a bit ahead of stuff. But basically, in assembly, like it's not even the lowest level there is. Beneath assembly, like when you compile your program into bytecode, it actually gets translated from assembly into bytecode. And where we only have one instruction for mov or move, there are plenty of different instructions that do that in our new instruction set. So we're gonna have an instruction to move a literal to to a register. We can move a literal to memory. We can move a register to a register. We can move a register to memory. We can move a. There's no use for moving a literal to a literal. I guess we could do moving memory to a literal. That's a good one. I'm not sure if like I'm hearing something real soft. I'm not sure if someone just trying to talk, which I don't hear, or.
Yeah,
You just have the lecture
microphone.
for CO on in the background.
Ah, I
Yeah.
see. I see.
But I just left it. Too much noise.
Okay.
Have it on quietly in the background in case he says anything fun.
But wouldn't
Yeah.
it be better to move the instructions to a separate class?
Yeah, I guess.
Probably.
Yeah, it would be. How would we include that? Because then we would have to. Well, I guess not really. I was about to say then we would have to. Like constantly. Then we'd have to initialize new thing. But if it's just a static thing, then we can just say. Bijvoorbeeld, if for example, if we have a class called instruction, we could just say instructions.movLitReg.
Yeah, you should probably just have an instructions class, which has
Yeah, well,
all
great point,
instructions,
guys.
line of statics.
Instructions. So then if I do this, and I go here, will I now be able, inside of like a class,
You
or
didn't
inside of a
make the static
function,
yet.
also this is a public void, or, no, I guess this is fine. But would I now be able to do like instructions.mov lit reg?
You forgot to make them static in instructions.
Ah, yeah. That's a good one. This is real cool because like I'm implementing that cool stuff, but I'm also learning new stuff about Java. What's my related problem?
That.
That's not a statement. Oh yeah. So if I can just say like system.out.println this. Okay, and now I can make Let's see. Is there a way to generate a main? Ah. Public.
You can do,
Static
Static.
void main.
if you type psvm and press enter, that's the shortcut for that.
Oh! Public static void main. Oh, that's cool.
Oh my god, that's great.
Oh, dude, this is why I love just doing stuff with other people, because I am a pro at Python. Well, I'm relatively good at Python. I have 8 years experience, but I know jack shit about Java. Like, absolutely nothing. So this is real nice. Okay, so in our class we can say my CPU is my CPU is new CPU. And just by initializing this, we should initialize our memory, our registers, and it should print out the instructions mov.litreg.
Well, wait. Doesn't this give any problems? Because you're initializing a class inside of itself.
That's fine. It's
Yeah, that's
static.
fine.
It is? Alright,
Yeah.
I get
You
Yeah,
have
as long as,
static
like,
method
main is
inside
a
of a class
static-
that's initializing in
Ah.
inches of the class.
Yeah.
Alright.
So now I can do add configuration.
You can just click on your main method to run it.
Seriously?
There's a button next to it.
Like,
There's even shift F10.
That button.
do.
Run CPU.main.
whoa! Oh shit! Oh, this is so cool. Okay, so now if I say move, wait, this is literal to register. But now if I say from a memory into a register, and then I run it, oh, that automatically makes that shit up here too. Oh, this is so cool. Okay, that prints 4. Oh, that's exactly what we want. Okay, so in our CPU, yeah, we're gonna have some more functions. So this is just initializing everything, which is fine. We're gonna have... Actually, since memory is public, I can just say my CPU dot memory, and I can literally myself address the memory here. Usually you would use setters and getters for this, but we're not that far into the program yet, and I think at this point it would be better to just literally work with the byte array ourselves. So let's keep a counter for where we are, and I'm gonna try a little trick here. I can say I is 0 or int I is 0. So now if I do memory I here and then plus plus, and I can say like the first byte should be mov instructions mov literal into register, or let's do literal into memory, and then a literal will be a long word, so we can just say, okay, this is going to be 0x12, 0x34, 0x56, and 0x78. So what this will do is it will move a literal to memory, and in this case the literal is 0x12345678. And actually I think there's a...
Are we going to do big or little endian?
Yeah, that's a good question. That's our next thing. I think the most logical thing would be to just have little endian. So like 0x12345678 is equal to 0x12345678.
Okay.
That's not the way it is in our thing, but it makes everything a little bit more readable, I think. Especially if we're going to be manually inserting our bytes into memory. I'm going to make a little shortcut here, so instead of saying CPU memory I and then I++, I can just do CPU I++. And let me get this straight, I think this first uses I, and then once it's done with that, it increments it.
Yes.
Yes.
Oh, that's perfect for what we're going to be using. Because that means whenever we add something to memory, it's just going to increase I. Oh, that's sick. Okay, so now we have our instruction, and it's going to move lit into mem. And we're going to make it relatively logical, so the instruction move lit mem will take a literal, which is a long word or a double word, and move it into a memory location, which is also a double word. So then we're gonna say move this into 10000000. So that means that the long word 0x12345678 will be moved into memory location 10000000. Let me add another 0 there. Or actually, how long is our memory gonna be? We will have a total of 4 bytes of address space, which means our memory range goes from 0x 0000000 to 0x FF. So this will be all the memory we're going to use, or going to be able to use. So creating an array of this size should be sufficient. Or actually, if it
I
is
think-
from 0 to that, we're going to have to +1 it.
Yeah, but
Okay, so then we have 0x1 and then 0000000.
perfect.
Ah, shit!
Oh damn.
Oh yeah, an array
yeah,
can
of
only be as long as the integer limit.
Oh,
And the integer is 4 bytes as well. Now you see, we're gonna pull a pro gamer move and say that our memory space is 1 byte less big because I cannot be asked to fix that. Okay, so if anyone now wants to move a byte to FFFFFF, too bad. Okay, so now if we have this, is there a way to quickly print like the first 100 bytes of a thing, or should I just make a look for that?
well, we
Probably just
probably
low.
need to-
Yeah, let's make a public void. It's not static, so public void print memory that takes an integer starting location. Can you have default parameters in Java? Yeah, right.
I don't think so.
Or like optional
can,
parameters,
you
like
can.
having int bytes
Not
is
in that way, but you have
Yeah,
to
you have to do it a
overload the,
bit differently.
you have to overload the
Yeah, if you overload methods, it's fine. But yeah.
Oh,
So I have another method calling this method that you can have.
oh yeah. If you just
that
okay, yeah.
close to it.
Int bytes, and then I can say here print memory starting location 100, like that, right?
Yeah.
Yeah.
Oh, that's cool. Okay, cool. Oh, print memory is capital M. And I guess here, oh fuck, that even says what it. Oh, this, I love this IDE. Like I cannot get over how cool this stuff is. Okay, so now if we
It's
have,
amazing.
yeah, it's awesome. So now if we have this, then we should say system or for I, which is a shortcut for I to, from 0 to that, and then we can say for I is starting location. I is less than starting location plus bytes. So this will move from our starting location to starting location plus the amount of bytes, and then it will increase it by 1. So then we can say system.out.println S, capital S.
You can use south for that.
As
South.
out is a shorthand.
Ah!
You can also call that on another thing, like if you do starting location dot as out, it will do system.out.println starting location.
Wait, seriously? So I could just say starting location.s out.
Yep.
Oh, this is, oh my god. I am learning so much new shit. This is so cool. Okay, memory I. So that means that it will loop from starting location and print well, how do we want to print this? Because if we're gonna print it as numbers, it's not gonna be as visible. Is there a way to byte to hex?
Yeah, there is a way. I believe integer to or byte to hex string or something.
Yeah, I'm
Maybe you
googling
can
it
just
right
type
now.
and see if there's
Let me
an
see.
alternative.
Integer to hex string 1.
Wait.
Maybe
Integer
you
to
byte
hex
to hex.
string Java.
Yeah, but it's
Wait,
not an integer,
never
so you might.
Oh yeah, that's
Maybe
true. It's
byte.
a byte.
Maybe there's a byte. I believe there's a
Or-
byte for that, but
Or you can use string.format and then wait. I'm gonna copy it.
fuck is this? Encode hex string, is that it?
I've put it in the general voice channel.
Okay. Ah, yeah, that looks alright. Okay, so if we're gonna do it like that. Okay. And that means we'll take our memory dot with an index of I. So it's gonna be 0x and then a 2-byte long padded hexadecimal number. Okay, I think that should work. So if I now go, and this will not do anything yet as of like actual instructing anything. Right now we're just moving stuff into memory and getting it out of memory. So now if I say in here, my CPU dot print memory, starting at location 0 and printing like, I don't know, 10 bytes, and then run it, it should print these bytes. Exception in threads, negative array size exception in CPU init, so that's at line number 10.
Wait, where?
Oh,
Maybe
this is
it-
yeah.
Yeah,
I think the issue is that it's a signed integer.
probably.
Probably, yeah.
Yeah, so 0x is actually a negative array size.
Just use integer.max value.
Yeah.
Then you can.
Wait,
Yeah, well-
integer dot max max value. Yeah, there we go.
7.
So that means that our instruction space is now effectively halved. Fuck.
Ah, whatever.
Not only is it effectively halved, it's effectively half minus 1. Oh boys, we're already off to a good start.
Making a computer in Java is a bad idea.
Yeah, I actually let me show you guys real quick how I got this idea. So if I start this up, go to here, go to coding, go to computer.py, and open with my Python editor. My editor, it's like literally the built-in idle. I've got like a whole
Download PyCharm.
Hmm?
Download PyCharm.
yeah,
It's
yeah.
in
PyCharm
connected
is a lot
Python.
better, but I just use this because I never switched over before. I've got like a whole instruction subset here. I've got like a different memory mapper class where you can print shit to a screen. Let me see if I actually have anything cool written in this right now. I think this is actually a way to create Fibonacci.
Oh,
So let me see if that works here. I actually think this doesn't work here, but that's because it's an infinite loop. So if I do this, and then stop it, and then print this, this should show the first. Yeah.
nice.
So this is creating Fibonacci, and then here, because it's only printing
then-
1 byte at a time, it's like, this is actually 0x01, and then the hexadecimal value for 121. But yeah, so I made this computer in Python first. It also has a screen where you can actually like print stuff to, and it does that using ONSI escape sequences. So here you can see like the ONSI escape sequences that I use to literally move my cursor across the screen and print stuff there. I made like my own little thing for that. But that's how I got this idea, and I want to do it in Java now. Requested array size exceeds. What do you mean? Our array is too big. Java gives
Just make
more
the size
RAM.
bigger. Dash
I got
XMX
more
is
RAM
the
dot com.
parameter. Dash XMX is the parameter.
Okay, and where do I do that? Like here?
Right there, VM options minus XMX, capital first X.
Capital first X.
then just
16
like-
gigs.
Yeah, capital G. Yep, like that.
Okay. Does this work? Apply, hub, run. XMX.
Oh, you put a space behind it, I think.
How many
Oh, yeah, okay,
gigabytes
fair.
of RAM do you have?
well actually let's see, this PC, properties. I've got 16 gigs.
I
So
don't know if
let's not give
assigning
16
all
gigs. I
your
thought
RAM is a good idea. To be
yeah, my
honest.
old PC had 32 gigs, but that was like
remove the space between X and Max
Yeah.
and 10G.
Yeah.
my old PC had 32 gigs, but that was like really bad DDR2 server RAM we still had lying around. Every
Still
what do
too
you
big.
mean?
It's still too big.
It's still what? That's bullshit. Okay. Exceeds size VM limit. I know that there's like this max and there's also this minimum thing like XMS, but let me try like if I create this thing instead of the full this big, I'll create it only like 0x 10000. What if I do this? Hey, Pog! Guys, look! It's whatever we wrote. It's like, here's the instruction move literal to memory, then 4 bytes of that, and then 4 bytes of this. Okay, so we're having a little bit of an issue with,
General VC channel should be the fix.
alright, that should be great, because I was about to say we'll just decrement our, like, we'll just use 2 bytes for registers instead of 4, but that's like way less cool. So, we'll make this the integer.max value again. Edit configuration here, and I'll just paste this here. Use compressed oops. And it doesn't work. Max perm size was removed in Java 8.0.
Oh, nice.
Did you do any of the bonus assignments for assembly, by the way?
Yeah, I completed assignment 1, 2, 3, 4, 4.A, 4.B, and 5.
Oh.
But I haven't started on 6 and 7 yet. I'm gonna do them, but I'm just taking a little break from it.
What is 6 and 7?
6 is encoding data in a bitmap, which seems pretty interesting. I'm actually gonna do that. And 7 is making a game.
Brainfuck.
Oh.
I am
7 is brainfuck, 8 is...
Oh yeah, 7 with brainfuck, 8 is making a game. I am probably not gonna make a game because it's like a lot of effort, unless you make like Pong or
So
some
you
shit.
didn't do the brainfuck one?
I might do the brainfuck one. I haven't done it yet though.
Okay.
I've started that one.
Yeah.
It's pretty fun.
Okay, so now if I just say instead of max value, I'll just say. Okay, so what I'm gonna end up doing is I'm gonna shrink down our memory address space, or actually maybe I can do like. No, 3 bytes is not a multiple of 2. No way I'm gonna do that. Ew. But that would limit us to like a real low amount of bytes. That would mean we only have like 0x FFFF bytes. So let me check how much that is. Oh, that's only like 6,000 bytes to store stuff in. That's like
That's not great.
Hmm?
It's not that great.
no, it's like 60 kilobytes of RAM. Jesus, that's small when I actually say it out loud.
Wait, it's a computer in Java. What did you expect?
Yeah, okay, that's fair. I mean, I guess we don't really need that much.
We should write a computer in assembly.
Oh god.
We are making assembly with assembly.
That's basically like Quine stuff. It's already assembly language.
Yeah,
Why would you?
I was about to say, let me just open the vi in.c. Okay, done. There's your computer. Okay, so we'll work with this memory space. I'm sure it's gonna be fine. Yes. Okay, so then in this case, we would only have this. So we would have, let's see if I print this. We would have one move literal to memory. Oh yeah, and it is 0 initialized. See. Oh, that's great actually. Oh, sick. Okay, so now our computer should actually, do something. So to do that, I'm gonna first on initialization. Actually, I think all of these will be set to 0 as well. Then that's gonna be great already. Then we don't have to initialize our instruction pointer. So how it's gonna work is we have an instruction pointer, and right now that points to this variable or this value in RAM. And it sees, okay, I'm gonna have an instruction that moves literal to memory. So it's gonna take a literal. A literal is always 4 bytes long. So it's gonna take the next 4 bytes, and then put that somewhere. And then it's gonna take the memory address, which will be 2 bytes long, and then do this, and then it will put this literal into that address in memory. Okay, so now I'll create a public void step, which doesn't take any arguments. And what step is gonna do is it's gonna I'm gonna remove these two, by the way, for now. But what step is gonna do is it's gonna execute exactly one instruction starting at the instruction pointer. So let me just execute one instruction starting at the instruction pointer. So I should create a first create a fetch. Now let's do this without fetch for now. So let's say okay, instruction is or int, I guess byte instruction in this way would be memory, and we're gonna take the byte from memory that is currently at the instruction pointer. So to do that, we need to get memory registers.
I think it would be more readable if you use the name instead of the index as the register.
But
Yeah,
that's
exactly, and
how-
that's like what we're gonna be doing our next with our next thing,
but how
because
are you
this
going
does
to-
not look fun. This looks like the opposite of fun.
Yeah, but also, how are you going to address a 32-bit register when you separated it in 4 bytes?
Yeah, exactly. So this is just gonna be like the very first thing, and from there on, we're gonna make it easier on ourselves by creating helper functions like fetch 62 or 32. I don't get why this doesn't work though.
You could
Requi-
probably just make a register
Oh!
object and have an array of that.
So
Instead of just
Right,
having the bytes
let me
separately.
get something started real quick. Right now we have an issue where we've got register 6 being returning a byte because register is a byte array. So we need to implicitly cast that to an int because or
Yeah, but
what? Cannot
this
cast.
is a byte array.
Oh fuck.
You
Okay.
need to- yeah,
For
that's
now,
not
I'm gonna
byte
work with
array.
only the last one, but we're gonna have to fix that. Let's see. We do little endian, so this is like the biggest. So the last one will be the smallest. So if I only use the last one, that should be alright. However, I'm gonna fix this. Don't don't worry. But okay, so we have the instruction, and then we can say, does Java switch? Oh, that's switch. Oh, even better. So I can say
Wouldn't-
switch instruction.
Wouldn't it be easier if you use a long array instead of a byte array for the registers?
It would. However, that like adds a layer of abstraction to our computer that is not there in real life, and I kind of want to keep it close to how it would be in real life. So instead of having like, well, I mean, you mean like a long array for the memory or for the registers?
For the registers.
All right. I guess in real life it would also just be a list of arrays. However, I, honest to God, cannot be arsed to like do this in Java this way. So let's see. Oh, that's not working. Oh yeah, Claire said. No. Because now every time we're gonna edit a register, we would have to individually edit one of the bytes and then check for overflows and stuff. It would work, and I did it like this in my last computer. Like here you can see, let me see to the actual computer class. I actually had a memory, like just a byte array, which is register times 4 long, and then I would like individually grab 4 bytes from it. But I'm just gonna make it an array of longs, which it's not as elegant, but it sure as hell works better. So I'm just gonna say register 6, which is gonna be the instruction pointer. So I can say switch instruction, and then I can say case instructions dot mov literal to memory. Why does this not work? Constant expression required.
Oh wait, it's not a constant expression, so you need to use a constant keyword.
Oh yeah, because this is like Okay, so I can do static, constant, or
Final.
constant static. Final?
Final.
Ah, yeah, that seems to work. I like how like, or it's like four, like this thing is 5 words, and only one of them is something we do, and the rest is just like keywords like final, static, public, byte.
Welcome to Java.
Yeah, I was about to say.
But you can do way better than that.
Yeah, like look at my fucking Python script. It's like move lit reg is 0x10. Final, static, public, byte, move lit reg is 0. Actually, I'm gonna change this a bit and move this to like up by 10 bytes or 16 bytes, 0x10, because that way when there's a 0 memory, it's not gonna constantly think it's gonna have to add or move a literant register. So for example, in our code here, it would read this, execute this command, and then see, oh, that's a 0. Oh, that means that we'll have to move a literal to register and start executing more. But when it gets to the zeros, I actually want it to not do anything. Okay, so in the case
Zero
of this
byte could be
instruction,
The 0 byte could be used as a return or an exit instruction.
sorry, what did you say?
The 0 byte could be used as a return or an exit instruction.
Yeah, we could. However, I think I probably want like different instruction codes for that. We'll tackle that maybe when we get there. Okay, so in the case of a instruction move literal to memory, we're gonna move 4 bytes, so that should be memory. We want to get 4 bytes out of memory. So I'll just write this in pseudocode real quick. So we've got lit is, or I guess this would be an integer. Lit is fetch 32, and this means like fetch 4 bytes from memory, increase the instruction pointer accordingly, and move that into lit. Then int mem is fetch 16, which is again fetch a 16-byte or 16-bit number from memory, so 2 bytes. That will be these, and put it into memory, and then I can say memory lit or mem equals to lit break. Does it have to have a default case?
No, it doesn't.
Doesn't have to.
Okay, sick. So this would be what we have for now. However, we don't like this also wouldn't work because we cannot just store a 32-bit integer into a memory. We'd have to individually change all these bytes. But this is a great idea for what we're gonna do, and that way we can start working on our instructions that will actually do this. So if we say fetch 32, that should be a public, whatever, I don't really care for public, private. And this is gonna return an integer. Or actually, should we do an integer? Because that's gonna be an unsigned integer. Because that way, if we have like a literal in our memory that's like 0xFFFFFF, it's gonna think it's a negative number. Can we work with... is there really no way to do unsigned integers in Java?
I am
You have to
currently...
put unsigned in front of it.
Oh yeah, that's a thing.
Oh yeah, unsigned is a keyword in Java.
Is
There's
that...
so many goddamn keywords.
Of course it's a keyword.
You have unsigned long int. That's just...
Let me see.
Everything keyword in this damn language.
Unsigned... No, it's not. Ah. Okay, so for a fetch 32, because it's gonna be like have an impact on a sign, I am just gonna genuinely make it long, because then we have more than plenty of memory, even on the left of it. And yeah, for a 16-bit, that's not a problem. So then we'll create a public long fetch 32, which will... for now, this is not ideal either, but we'll just say int IP, which stands for instruction pointer, is the current instruction pointer. Then we're gonna say we're gonna get the 4 bytes from memory. So we can say memory instruction pointer plus plus. We can say like byte 1 equals to, and this is gonna be a byte. And then we can individually get each one of these 4 bytes from memory. And then we can say registers 6 equals IP. Or then we'll have to... Yeah, that's going to be a long, so we're going to have to implicitly convert it to a long. Alright, so... Do you guys get what this code means? Like what this does?
Yeah.
Yeah.
Okay, sick. Now we're going to have to create a long, which is the result of this byte. Long result. Which will be byte 1, and what I'm doing now will declare the end units. So byte 1 times 256 to the power of 0, which is 1, plus byte 2 times 256, plus byte 3 times 256 times 256, plus byte 4.
Maybe use the hex codes.
Yeah, that's a good one. I can here say like 0x 100000.
Oh, that's way better actually.
Yeah, that's a lot better.
So, let's have a break and then we transfer.
I think the last one needs another 0.
No.
The last one has 5 zeros, so it needs to have 6.
Wait, what is going on here?
Okay, so right now we've got our byte, which in memory will be represented
No,
as
no,
byte
like-
1, byte 2.
What is going on in general?
Oh, okay, yeah, I'm creating a computer in Java. As in like a literal CPU with registers and memory and an instruction set and everything.
Yeah,
Holy
byte
shit.
4 times
Okay, this is sick.
million, not 100,000.
Ah, good call.
And you're missing at times as well after byte 2.
Yeah. Okay, and it's also probably gonna give me an issue because... Or actually, if it can convert all the integers to long implicitly, that would be great. Does this work? We'll see. Return result. So we're getting each one of the bytes, converting that to a long, and returning that. So this works. Then I can copy and do the same for fetch 32. Or fetch 16, which will literally just do the same but only for 2 bytes. And it will remove this bunch. Is it even needed? I don't think so. I think it converts between long and integers implicitly. That's really cool. Okay, so oh yeah, I guess it can be an interval. Yeah. So this works. However, we don't have the other instruction yet, but to test if this works, I'm just gonna say lit dot what was it? Outp sout. Hey, and then do the same with mem. And this is just a way to test our things. I'm not gonna make actual tests because that shit is hella gay. I'm just gonna test as we go. So, do we have any more syntax errors? I don't think so. Run main.
You're returning a long, I think, instead of an int.
Ah, yeah, there we go. So this should just be int. Run. Oh, yeah. Okay. Can you guys guess what the problem is?
Oh, you haven't got step, right?
Exactly. So now if I do my CPU.step, we'll eventually make something that way you can say my CPU.run, it will execute step infinitely. But for now, just step is good. Oh, this is great. Okay, and now to see if this is actually what we want, I'm gonna open Python. I'm gonna open Python a lot during this. And this is not what we want. 1 1 1 2 3 4. Oh, yeah. Not only is that the issue, but when we get this instruction, that is also Yeah, we're getting something here, so we should move the instruction pointer up by 1. I'm gonna make another function, just called fetch. And that will fetch a singular byte from memory, and
Then
return
you just don't need all this shit.
Hmm?
Or most. Then you can make it a lot easier, I think.
Yeah, exactly. Like I'm gonna make a lot of stuff, like a lot of small, really tiny functions, but that's just because the CPU is gonna execute those tiny functions so much that it's just gonna make everything a lot better in the long run. Like I'm also gonna be making functions for executing, or like for getting stuff from registers, setting stuff to registers, and everything like that. So now I can say instruction is fetch however, oh wait, actually, I was about to say that doesn't work because we need to fetch at the location of the instruction pointer, but we are already doing that. Wow, I'm good. However, this is not a byte, this is an int, so I can say int equals to, or yeah, casting, or a byte instruction equals to conversion to byte fetch. So this is gonna fetch 1 byte at our instruction pointer, and that's gonna be the instruction, and also increment the instruction pointer by 1, which is great. So then it should print the correct stuff.
Why would you convert it back to an int and then back to a byte again?
Because right now we've got a switch, and the switch looks for instructions, and the instructions are in byte format. However, in most of the cases, we would just...
I mean the fetch function.
Yep.
Byte 1 is a byte, then you convert it back to an int when returning, and then you convert it back to a byte again.
That's because the memory itself is as an array of bytes, so we get it as a byte. However, in most cases, I'm gonna be using it as an integer because I'm just gonna, like, for example, if we add stuff and we just want to add like a single byte, we're never gonna do that, by the way, but just like an example. I'm gonna want to treat it as an integer, not as a singular byte. I think. Actually, you are making a solid point. Like, if I just say byte here, I think you can do most of the stuff you want with just bytes. So, if I remove this, I'm not sure if you can add and subtract and stuff with bytes, but if it works the same as just an int, but then, like, you know, with only 1 byte of memory taken in, then we're just gonna keep this. That would be way better. That's a good point. Thank you for bringing that up. Okay, so we still got everything the same, but I think we might be converting indeed what someone said before, little endian to big endian. Yeah, there we go. So this should be byte. Oh yeah, byte 4 should be the smallest one. Byte 3 should be the second smallest. Byte 2 should be this. Yeah, okay. And that makes sense because when we store it in memory, it's gonna be byte 1, 2, 3, 4. So 1 should be the one with the most importance. Yeah, that makes sense. Does it make sense for you guys as well? Because I say it makes sense now, but...
It does, but don't forget to change it in FET16 as well.
Yeah, and yeah, that's a good one. Oh yeah, let me just do it like this then. Yeah, that could have been a real annoying bug. So thank you for saying that. So now we have this number instead, which already seems a lot more logical. So if I say hex this, that's the right number, and if I say hex this, that's also the right number. Awesome, guys, we're getting somewhere. Now to actually implement the logic for this function. So we're gonna make another function that is a public void write 32 add. That takes a long value and a int address. And what this function is gonna do is let's see, write the value to the address in memory, and let me just add 32-bit the value to write, the address to write to. This really shouldn't have to be said, but I'm just gonna do it anyway. Okay. So now we've got a long value that we're gonna write to an int address. So let me see, how are we gonna do this? Anyone of you got an idea? Okay, that's fair.
Maybe first dissect the value to multiple bytes and then just assign them.
Exactly, that's what I was looking for. Nice. Okay, so
You can use a mask for that, an end mask.
yeah, that is actually something I was looking to hear. That is really good. Okay, so we can say byte 4 equals to or byte 4 equals I did byte 3 equals to byte 2 equals to and byte 1 equals to. We're gonna fill that in later, and then we can say memory address, and I guess we can just say plus
Yeah.
equals to, and then to do endianness,
One.
yeah, just do byte 1 first. Like we decide what is byte 1 whenever we do it, so we can just do like this, and that should be it. Okay, so yeah, it doesn't have to be done anymore.
The mask for byte 4 is 0xFF. Then
Binary and
0. No, just 0xFF.
why is this not working? Ah, can I implicitly convert this to a byte?
I don't think so. Not directly. Maybe you first need to shift it down.
Yeah.
Because
We like it's not already a byte right now. We've just got like for example, say value is 0x 1 2 3 4 5 6 7 8 like we did before. So now at this point it's gonna be 0x 1 2 0 0 0 0 0. So to fix this, we're gonna byte shift over to the right by let's see. So we want to get rid of 1 2 3 4 5 6 bytes. So that is 6 times 8.
48.
48. Why does this not work? Cast to byte. What? No, I don't want to cast it to byte. Okay. Let's see. What is this error exactly? So we've got a value. We are ending that by.
Byte 4 is the lowest one, so you should end it with 0xFF, not 0xFF0.
Oh yeah, that's a good point. And then we shouldn't do that at all. So this one is easy. So in this case, that should be 0.0000078. The next one is going to be a lot harder. So that's going to be a byte of value, and let me just do it like this: 0.00000FF. Binary and 0x0000FF00.
Oh wait, no.
This will leave us with 0x00005600. So we need
Yeah.
to move shift it over.
Yeah.
So as of now, this is still a long. So let me just Google.
What are you guys working on?
We're working on making a computer in Java.
Oh, nice.
Yeah, as in like with memory, registers, instruction pointer, and everything.
So this should run assembly code
Not assembly, but it runs
or
bytecode.
machine code.
No,
Yeah.
not yet. There's actually I made
Yeah,
this
but
first in Python, and I was following along on somebody else, but he just went out of his way and made a full. I'm not kidding. A full interpreter for his own assembly language that would convert it into the bytecode you're writing now, and you could literally write assembly, and then you could even go a step further and make a C interpreter and actually write.
Why
C
don't
for
you
your
Why don't you just go all the way and make a breadboard computer?
I actually a friend of mine has actually done that. We probably have the components to do that at home, but this is easier and way less of a bother.
I totally want to do that with whatever budget I have left over after, you know, living.
Let me tell you, if you're at uni, not much. Okay.
Well,
That's where I lucked out, because instead of spending money on living, I am getting money for living.
Hey, duo. Hey. Okay.
Hey,
Let's get
owning
back
an
to.
apartment. Hey.
Let me get back to this bit shifting along in Java.
Maybe it returns an integer instead of a byte, and then you need to guess it again after bit shifting.
Yella.
My name is Jurre, but yeah.
Yeah, Jurre, I mean, Jurre Yella, you know.
Yeah, but my brother's called Jelle Jurre, so.
Oh.
Yeah.
Segfaults.
Alright, what's up?
Segfaults are fun.
Can we kick whoever said that? Anyway, what's up?
It's drop table.
Bye! No, kidding. No, he actually contributes to this lecture, so he can stay. What was your question?
No, just segfaults. And also, yeah, R4 for assignment 3. What registers basically can we use in the inside of our thing?
You can use only everything except for our BX and our 11 or our 12 to our 15.
Okay, so we
can use them.
yeah, but we have
you
to
can
push
use them, but then you first have to push them and then afterwards pop them.
Yeah, because I had a problem with the R14. I tried to push and pop that, and when I tried to do that, that one segfaulted me.
It could be that your stack isn't byte aligned. Or like 16.
No, but I push RBX first, then I push R15, and then I try to push R14, and suddenly it when I try to push R14, that one causes it to segfault.
I have never ever in my life seen a push cause a segfault before, so that's interesting.
Yeah.
However, I'm currently in the middle of this thing with like more than 10 people listening, so unfortunately I'm not gonna be able to help you now. If you shoot me a DM afterwards, I might be able to help you.
Ah, great, man. Yeah, there. I uncommented them. Suddenly it's a fucking segfault.
Did you look through it in GDB then? Because that might be replaced with.
Don't know how to read the GDP. It's really
Okay, fair.
doesn't make much sense to me.
That's fair. Hey guys, I don't think it's giving an error. Let's go, boys. So if I just do this and then instead of this do 32. And then
I'm pretty sure you're now shifting the 0x00ff.
Oh, if that is the case, I'm gonna be pissed.
Because I'm pretty sure it says that in the warning as well.
You can just use parentheses.
Yeah, use parentheses.
Yeah, I will. But first let me get this this straight real quick. And let me check if this says you can replace that. Yeah. Wait, what? No.
You have
That's
to
actually really
put
cool.
parentheses around value and the 0x value.
Yeah, the problem earlier was that I believe bit shifting returns an integer, but now it's being converted into a byte after the bit shifting has been done. So.
Let me just write this real quick so I have an overview of everything. That's the 9. It's always 0. How is it always 0? Let me see. I did this the same way in my Python program. Let me see how I did it.
Maybe
Yeah.
you need to finish the code without errors, and then it will show new warnings. Not sure, but you missed parentheses there, so I might want to add it first.
I don't think I'm missing parentheses anywhere.
No, he isn't.
Now, well, alright.
you
Oh
have
yeah,
to-
well.
Oh
you
yeah,
misplaced
maybe for
it.
this one.
Yeah, you
Yeah,
misplaced
put it in the wrong place.
Yeah.
So now that one is fine.
Oh, are you fucking kidding me? Okay, let's see if it runs. It runs?
Oh, it's because it's not cast to. If you cast it to a byte, it fixes it.
No. Well, I
You
mean,
need
everything
more
here is cast to a byte.
bytes. Yeah, cast value and 0xff.
But
casting
why
them.
does it work with this one?
Casting twice. Oh my
Yeah,
god.
you have to cast that, then it fixes it, I think.
Why is
Wait,
Java-
now these two.
No, what?
Oh no, no. This does not fix it at all. Because right now we're converting it to a byte, but then the overflow will just get lost. So when we do
Actually, yeah.
that, it will turn anything above 0, 0 on the right side to just disregard it, and then everything will be 0. Let me see if this code actually functionally works. So I can say print location starting at 0x1000, and I can print 10 bytes there. Yeah, that should be fine. And let me see what happens.
List so far.
Okay, it's still all zeros. That means these 4 are still all zeros.
How long have you spent on this?
The one in Python or the one in here?
This one.
I started an hour ago.
Damn, and you're already.
Yeah, but honestly, that is because I already had, like, I've seen somebody else do it in JavaScript. I've done it myself in Python, and I'm now doing it in Java, so I already see, like, 3 different ways and approaches to doing this.
Compared to which case, it's way easier.
Yeah. Like, I'm so confused, though, because here I do the exact same thing. Value, binary, and 0xFF, whatever.
Wait, are you even
Wait.
calling there?
Wait. Oh my god, I'm dumb! Holy shit! Oh, that hurt.
Oh, yeah.
Yeah, every single one of these is a nibble, and a nibble is only 4 bits long. Also, that is like genuinely the way that we as programmers name them. We have bits, nibbles, bytes, megabytes. It's all just
It's all just chunks.
yeah, it's all this chomp. Okay, so now if I run this, oh, it still doesn't work. Bog, we're gaming. Okay.
Just making sure you're calling the right at function, right?
Fuck.
Oh, that's
Right,
fine, that's fine.
32 at lit mem. I was like, why is it not working? Well, now we found out.
I like how
I think
the
you're
team's
responding.
asking you if we want to get chat closed again.
Hmm?
That works.
They're asking if we want to get chat closed again.
Yeah. I don't think you can get sec faults in Java. I think it's a little smarter than that. Okay, it's still not working, but it's working less bad.
Isn't it?
I feel like yours going insane slowly.
Oh no, it isn't actually. Oh,
Slowly, slowly dying,
Okay.
dying away, day after day.
Are you
Yeah.
printing the right memory here? Why do you do 0x1000? Why do you do
Because I am writing to 0x1000 here.
Okay.
However, let me just check this real quick. No.
And
I
how-
know. I know by myself that literal that my memory is that, and I can say, yeah, we already checked this. So this really is hex 1000.
Can you scroll down again?
Um,
No. Yeah, but how big was your memory again?
one
Should be
10000. Otherwise,
Oh,
we would
yeah.
get an error, like the memory index out of bounds exception or something
Yeah,
like that. Okay, let me check real quick, just to be sure that inside of here, that I'm actually working with the right values. Value and address.
You might want to add some extra strings there.
Yeah, so the value is this, and the address is this. Wait. Oh my god, I'm printing 10 bytes instead of 4. Oh my god, it was already working! That's why there was no error.
Nice.
Whoever told me that it was already working, and I said, nah man, that's just the things. No, those are way up
I
here.
did.
You were right. Okay, so now we have write 32 at. That's great. That means that I can now just copy this and make a write 16 at. Just, I'm not sure if we'll ever use it, but you know, it can't hurt. Write 16 at. That means we'll only have these two. I can remove this. I can remove this. And I can say these two, and then this should be bytes 1 by 2, and this should be by 1 by 2. Is that correct? No, that should be byte 2 byte 1. Yeah, okay. And this should be byte 2 then. Okay, so now we have the code to write 32-bit memory address or value to a memory address, and a 16-bit memory value to a value to a memory address. Okay.
What- Just any attempt I make to push R14.
Wait, what did you say?
Any attempt I make to push R14 onto the stack, it just segfaults.
Do other registers work?
Have you checked that it actually segfaults at that line and not something like
Well-
scanf?
Well, every time I comment it out, it no longer segfaults.
Well, that doesn't mean a segfault at that line. It just means that
Yes,
that
but it means
causes
that
the
that's-
segfault.
that
Try
is-
pushing try putting like a 0 beforehand, and then popping also it into another register you don't use afterwards anymore. Because that way, I think what you're doing is you're unaligning the stack, and then during a printf within your function, it
Yes,
will.
but why would that unline my stack when every other push functions
Well,
normally?
you need to push in two, like in multiples of 2. So if you push 0 values, the stack is 16 bit aligned. If you push 2 values, it's also 16 byte aligned. But if you push 1, it's 16 bytes plus 8. Everything you push is always 8 bytes. So you need to push 2 things to make sure that it's properly aligned.
Or you have to subtract the...
Yeah, you can also subtract or add, or in this case add 8 to the stack pointer, but not quite.
Let me just try then that push Q 0.
Yeah. Meanwhile, we can see that our thing works here. Also, in the computer organization channel, there's somebody who is like talking to you about this, like the Nick AC one, Nick AC 11.
Yeah, I typed it in.
Yeah, in the
Okay.
computer organization channel. So you guys work that out. I'll continue with this.
By the way, for the right 16 add, you can use an int value. Because you can use int as the value, not the long.
Oh yeah, that's true. But yeah, okay. The fetch 13 also fetch 13 16 returns an int, so that would be like best. Yeah. Okay. So now we have this. However, there is still something that I don't quite like, which is that we have to get the registers manually. I'm not sure, because this is...
Ah, great! It does not segfault.
Hey! Bonus puntjes.
Hey.
You can make a class inside the CPU that is just like EAX is this, right?
Yeah, I can make a dictionary, I guess. Also,
Now I just
I'm just using a enum for my registers, and then having a hash map with the register and its value.
Okay, guys, we've got a little bit of an issue. So the instruction pointer is a long. Yeah, it's a long. However, to address memory this memory, we cannot use a long. We only can use an integer.
Oh.
Pretty sure
So-
you could just cast it since your memory isn't bigger than an int anyway.
Yeah, okay. Yeah, that's actually a good point. My memory will never be bigger than an integer. Yeah, okay, cool. Okay, problem solved. Thank you, guys. We can go back to fixing shit now. Okay, so now this instruction will literally just be fetch 32 lids, fetch 32 16 mem, write 32 add lid mem. I'm also gonna add some other stuff here that's not necessarily instructions, but should I do that? I want to have like this stuff somewhere where I can just say registers.eax and it will give me the index of EAX. Register class! Yay! New class!
Don't you have like macros for that in Java? I don't know.
Yeah, you probably can. However, we still want to be able to access it using integer, because if I'm gonna write, for example here, move a literal to a register, I need to be able to represent this with just a number. So if I say like 0x00, it's gonna write it to the 0th register, or like 0x01, it's gonna write it to the first register, or the second register in this case. So I'm probably just gonna stick to this where the registers are named like this, but I'm just gonna make a new class registers. Where I use this syntax, and then instead of this I have, let me copy that over from here real quick. I have EAX, EBX, Why is this an issue? Oh yeah, cloth instructions, cloth. Wait, why am I changing instructions? Give me a sec. I was about to say that's not quite what I should be doing. So I have EAX, and I'm gonna be using the EAX EBX calling convention, or not calling convention, but like the naming convention, purely because that is how we name like 32-bit or the 32-bit registers, and we are dealing with 32-bit registers, so that's like what we're gonna be using.
You might also, but never mind.
Okay, so now we have EAX, EBX, ECX, EDX, EDI, ESI, and then we'll also have the instruction pointer, EIP. And then I'm just gonna put these in order.
Why?
Hmm?
Why is this loop doing this? It's
Whenever you're doing a print, it will probably affect the other registers. If you're not thinking about that, you gotta push your values before you print.
yes, that's what I've done. I've set up a push and then I've set up a pop at the other end.
Just like during the print, like
Outside my print loop.
well, the print is still gonna affect the variables during the loop.
Yes, but the loop isn't the variable isn't used within the loop, so.
Well, it is like you have a looping variable. That's how it works.
Yeah, but I mean my R14. That's why I'm pushing and popping it.
Oh. Yeah. Okay. I don't know. I'm gonna continue with this. Okay. So, right now, wait. We already have a fetch, just a normal fetch, right? No, we don't. Oh yeah, we do. Oh, Polk, dude, we're gaming. Okay, so now I can also make another case. So now I can say case give me a case.
I think it would be more readable if you move those to the instruction class. Like the execution of the instruction itself, that you move to the instruction class.
The issue is that this is inherently something that is done in the CPU class, so I cannot just move this somewhere else, unfortunately. Why can I not put this on the same line as what?
You have to do Shift Tab.
Shift tab.
It's infuriating, but
Yeah, you have tab here, Shift tab here. You can do that for multiple lines as well. I knew that, but I didn't think it would be this nasty and just like keeping me there even after I braked.
yeah.
Yeah, okay, now whatever. So then we can have move a literal to a register. So I can say the literal is it's already defined in the scope. I don't care. Long lit int mem.
You can also put brackets around your cases. Then the scope is fixed.
Brackets like this?
Oh no, yeah, well, with you can you still need a colon, of course, but you can I think always add brackets.
Oh, so you're just saying like this, so it creates a new scope for it.
No, curly brackets.
Oh, so like this.
Yeah, I think like that. I think that.
It's because you define lit and mem outside of your. Yeah, there. That's the issue.
Oh,
You
oh,
don't
this is
need
cool.
to make it a new scope since it's inherently a new scope, because cases already do that.
All right. Yeah. All right.
Okay, so now it at least prints before it seg faults.
Okay, so
Now
we have,
IntelliJ is angry at you because it's the same code.
yeah. So now we have move literal to register. I can say lit is this, the reg is this, and then instead of doing this, I need to say registers reg equals to lit. So now if I do this, and I say move literal to register, I have the literal, I have my register, and this will be EBX. Then I can say, instead of this, somebody mute him, please. Katana, you have 10 seconds to mute yourself, otherwise I'm gonna do it. 1, 2.
Wait, you can mute someone?
Yeah. 4,
yes,
5. There we go.
Yeah,
Okay.
it's like,
So now I
Yes,
can say
you know, I
my
got-
CPU dot registers dot in this case it would be 1 and then dot out s or s out. Hey! Oh, this is. I cannot get over this. So then I print this, and this should. My code here, before I spoil it, my code here should move 0x 1 2 3 4 5 6 7 8 into register number 1, which we know from here is register EBX. So if I then take register EBX from here, and I can do this by either doing like CPU registers 1 or CPU registers.ebx. That works as well. That shows me the content of register EBX. And if you look here at register EBX, I can say hex this value, and that is correct. Alright, we're getting somewhere, guys.
Nice.
So now we can move stuff around from registers to variables, variables to registers. I'm going to set up like the rest of the instructions that I defined here as well. But that's just because that is like super simple. So I can say move register to register. That is, oh, that is another case here. I'll just copy this. Also copy a new line along, please. There we go. And I can say move register to register. I'm not done coding. Stop fuck. Reg 1, reg 2. And these will both be ints. And that should be fetch and fetch. And that means I can do registers reg 1 equals to registers reg 2. But now I'm going to be consistent, because move register to register has a different format than AT&T syntax than Intel syntax, and we're mostly adhering to AT&T syntax. So move register to register means we move the first register into the second register, so I'm going to have to swap these around. So we can say the content of the first register will be moved into the content into the second register. So this should be correct. That's great. Okay, so we've got move register to register. We've got move register to memory and move memory to register. Move register to memory. So I can say reg and mem. And this will be a fetch 32. So then I can say write 32 at. Oh, this is so nice. We already made all this shit. At the memory address, or yeah, this should be a long gun. At the memory address, write the content of registers reg. This should. What is the syntax for write 32 at? The value and then the address. Why did I make it that way? That's stupid.
Could still change it.
Anyway.
I
Shit.
think if you refactor it in IntelliJ, it should change all your methods and uses as well.
Oh, that's
Oh,
cool.
seriously?
Pretty sure
Oh
it does.
God.
Yeah, this shit is like really cool. Honest to God, IntelliJ is like.
In signature.
Why does it give me an operand?
Oh yeah, you can do that.
mismatch
You
for-
can totally do that.
Wait,
Probably.
an operand mismatch for which instruction?
for mul.
Then you're moving the wrong shit.
For mul q, and I have a $8. What?
You can't
You
use it
just
on-
send the very instruction in CO and I'll tell you what's wrong.
You can't use literals from a mul instruction.
You can only
Wait.
multiply by registers, so you need to store it in a register and
Ah.
then multiply by that. Anyway, back to your.
Move a memory to a register. So I can. Oh, I also need to make a fetch 32 at then. And fetch 16 at. For now, I'll only make a fetch 32 at. But that means instead of the instruction pointer, I'll take an address, which will be a long address. And then I
What
can
you
say.
do is overload the fetch 32 with
Yay, segfault be gone.
so like you have an
Yeah, you
function
could
that
overload it.
fetches- Yeah.
Like overload the. Have like a write fetch 32. And then that should be an overload of. Just fetch 32 with an instruction pointer. Of with
Yeah.
Yeah. That might be better.
Yeah, that actually might. That's interesting because I couldn't do that in Python, but I can do that here. So the fetch 32 should call return fetch 32 of the integer of register 6, like this.
Yeah, but don't forget to pump up IP then. IP
That's
also needs
done
to be
in the
increased by
other function.
Ah, yeah. Okay, so let me see. I need to remove this. I need to just literally take away this. Do I have it there? Yeah. And then this should be... Oh, ooh.
You have to assign IP again.
Yeah, but... Hmm.
You can do that after. You can just
Yeah,
you
yeah,
can
I could just
leave it
do like
there.
here.
Yeah.
Yeah, I'll do that in here. That seems fine. So I can just say int IP equals to this. Return value equals to this. IP equals to IP plus 4.
Yeah.
And then... Oh, actually...
IP is IP plus.
Yeah, I was
4.
about to say, that's like not directly linked to our registers thing. So I should do registers 6. To make it more rigid...
Why not pluses? Pluses is superior.
Equals to IP plus 4. And then return value.
Okay, why?
Okay.
Why does R14 always return 0 here? Is the real weird thing now. Now I have an R14 that for some reason always ends up 0 and just exits my decoder. Even though the next value should not be 0.
I'm gonna be real with you, Chief. There's a bunch of people here actually working on the project. I would appreciate if you just would stop talking about your own assembly code here. Like, I'm not trying to be rude or anything, but I'm just like, it bothers the other people as well.
Okay, yeah, sure.
Okay, thank you. Okay, so now we have the fetch 32, which will just do fetch 32 of the instruction pointer, and then adds 4 to that, and then returns it. Then I guess I should do the same with the fetch 32, fetch 16 and fetch. I really should. But that's a lot of work. Ah, whatever, I'll do it. I'll copy this, put that here. Create a public byte fetch, or a int fetch 32, or fetch 16, without parameters. And that will say the same code as this one, except for that this is IP plus 2, return value is fetch 16 IP, and
it should be an int.
Yeah, this should be an int. And then fetch 16 doesn't take an address yet, so then I'll say int address, and I'll use that over here, and take this away. Okay, that seems fine, and now the same for the public fetch. Yeah, it's a lot of work, but it has to be done. And I'll create a public byte fetch. Oh, that is literally just this code. Instead of this, it will be 1. The IP is that still, and then I can say byte equals fetch at the instruction pointer, return that. Okay, that works. Now I can say here int address blah de blah. Oh shit, too much. Instruction pointer, remove that. I don't even need to actually do this. Okay, I think that should be it for all my fetch 32 adds, fetch 32, fetch everything. That should be all I need. Alright, let's have a look. I really should also make a... Like, all the tiny functions we're making here is really just to make sure that we I keep forgetting. I shouldn't code and talk at the same time because I keep messing up. But all these functions are to make sure that we actually have the functions if we need them. And hell, we don't even need this. We can literally say value. Okay, so now we've got all the. Let's see. Okay, all the fetch instructions from address, and this is all the write instructions from. And then the from EIP doesn't make sense because you don't write to the instruction pointer, you only read from it because it points to the instruction. Okay, so now we have everything we really realistically want. Okay. So, let's see, was this one working yet? Write 32 add. Yeah, because this is a memory address. And our memory addresses are only int. Oh yeah, so this should be fetch 16 then. Because our memory addresses are integers. It doesn't make much sense to do it the way we do it.
Here, one comment.
Yeah.
I fixed it. I'm an idiot.
Alright, happens. Glad you fixed it. Okay,
Turns out
cool.
I forgot to push RDI.
Ah, yeah, there we go.
I lost my RDI.
By the way,
Hmm?
you're doing the same thing as moving memory to a register and moving register to memory.
Oh, yeah, good call. So, move memory to register. So now I have the value at register. So then I can just do registers at the index of reg is equal to mem. Do I have to implicitly convert that because these are long? Ooh, that's now we're getting an issue, kind of. Because we are very limited in our entire use case of everything. Because like we can only write 16-bit values to memory and only read 16-bit values from memory. Because can we? Move memory to register. Registers reg is mem. Oh wait, I'm doing something wrong here. Yeah. Okay, so we're still missing 3 instructions. And those instructions are oh no, we don't. Oh, fuck, we already made those. Holy shit, I'm good. So then I can say fetch 32 from an address, namely memory. So anything with memory in it should do that. Yeah. Okay, so I think we're good now. So what we've done now is for the move memory to register is we load the values and we move the value of fetch 32 at that memory address into the registers of reg. So that makes sense. I think all our code should be working now. Everything like that we wrote so far. That's really good. Okay. Alright, we're getting somewhere. Let's actually make something that we can use. Because right now all we can do is move stuff out of registers, from registers to registers. What instruction are we going to do next?
Add.
Hell yeah. That was actually the answer I was looking for. So I can say, I'm going to like divide my instructions into multiple like subclasses in a way. But not like actually in there, but just in my head. So these are all the mov type instructions. And then we also have some arithmetic instructions.
I'm gonna look my instruction table. I have my own instruction set.
You made your own instruction sets at a time?
I've made a computer in logic gates.
Oh, that's fucking cool! Whoa! Wow, that's cool. Okay, nice.
See.
Okay, so we have... I have no idea how to spell. How do you spell this? I like how it even says that I'm wrong.
I believe arithmetics, but
You can Alt Enter and it shows you an option to fix it.
Arithmetic.
yeah, it's
Without
with,
Change to.
with an E instead of an A.
Oh! That's cool!
Arithmetics.
That's like
Wow,
the
I don't
most
even have to
useful
know how to
feature.
spell anymore. This... Oh, fuck, cool. Okay.
Guys, we're doing arithmetics, which is like arithmetics, but even more math.
I see. I was thinking of like mathematics, arithmetics. But it's like mathematics, arithmetics. That makes sense. So we have add a register to register equals 0x. And now I'm gonna do something that is... Actually, should we do that? So the systems I've worked with before actually have an accumulator register. Which is basically just when you do something like an arithmetic operation, like adding, multiplying, subtracting, moving bits, whatever. It gets moved to the accumulator register. And then you can use that register just like you would any register. So instead of doing add RBX2, you would say add RBX2, move accumulator RBX. So now we have the decision to either use that or just straight up not. I think I'm just gonna go with not and just have everything moved in place. Because I want to keep it close to the to what we're working with in real life as well. So we have add register to register. We can have add a literal to register, and that's it really. Then we can subtract the register from a register, subtract the literal from a register, and we'll do multiplication later. But just to make sure, I'll do that already. Lit to register. Okay, so now I can go to the CPU and add a function here that says move.
And it is quite easy for you as well to just have one
that is solved.
instruction, add something plus something, and you can then
cheese.
figure out if it's a register or a literal.
Is the next one?
Not really. If we were writing assembly, yes, that would be the
Well,
case.
Yeah,
Is
but
that
if you write an assembly, then yeah. But
16?
here, like,
From bytecode, you can't figure out if it's a
Well,
literal
Yeah, like
or a
all the
register.
computer knows is that these are the values in memory, and it cannot decide like, okay, the next 2 bytes make up a valid number, so it's the number that I'm gonna add, or the next 4 bytes make up a valid address. It doesn't work like that. We literally have to like specify, okay, we're moving a literal to a register or an address to a register or whatever.
okay.
Yeah, if you work with like assembly or making an interpreter from assembly to bytecode, that's what we're writing now. So we're not actually writing assembly. Then that could work, but unfortunately not now. Okay, so we'll make a new instruction called mov add register to register. Or let's start with add literal to register. Literals are 32, so I can say long lit equals to fetch 32. I can say long or int register equals fetch. And I can say registers fetch registers reg equals to registers reg plus lit. And now the thing we've got going on here is
You can use plus equals.
Hmm?
You can use plus equals there.
Yeah, that's true. However, if we add a literal to a register, we add the literal to the register. So first we define a literal, then we define a register. Yeah, that's how we do it in the AT&T syntax as well. So I'm sticking close to that. So yeah, here we could use plus is, but I'm gonna keep it a little bit more verbose than needed, just to make sure I'm getting the point across.
The second parameter is always the destination. In AT80 syntax, the second parameter is always the destination.
Yeah, I always keep it in my mind that I can add into between the 2 words, and it will say what it's doing. So I can say add 4 into REX, so I know, okay, that makes sense, and add REX into 4 doesn't. About that, me and my brother actually thought of a way to to keep in mind how it works, and the way we do that, if we do a fat whip with our left hand, and then we whip into the 2. So okay, the first one is from, second one is 2. It doesn't make much sense, but it's like something me and my brother used to actually remember it. Anyway, we have a register, which is just a fetch. Which is just a fetch. We have another register, register 1, register 2. And I can say register 1 equals to register 1 plus the value of registers reg 2. Is that correct? No, that's not, because it should be register 2 equals to register 2 plus register 1. Sure, boy, I sure love my own syntax. It's sure not confusing in any way, shape, or form. Let's see, then we'll do the subtracting next. And multiplication wouldn't be too hard. Though I might... The question here is, are we going to work with overflow like we are in AT&T? Where we have like, if the number is too big, it's going to get stored into 2 registers or not? What do you guys think?
I don't know.
Yeah, I'm just gonna go ahead and say that we won't, purely because I CBA to actually do that and implement the logic for that. Like implementing the logic for it would work, but like implementing the logic to work with the output of that would be a little bit of annoying. So I'm not gonna. And if I want to, then I can always do that later. But I can like literally just copy paste this. And I can just say minus. Whoa! I made some really interesting, complex functions, guys. Totally is hard. You should pay me on Patreon. So now we've got the subtraction. We've got the the addition, subtraction. Let's do multiplication next. So if I do the same here. I could say mole. However, we have to keep something in mind here. Because if we do this, if there's an overflow, it's going to cause some issues. So the way we can fix this, if we can say binary and 0x ff. Is that correct?
Aren't you gonna use the REX as the multiplicand for the mill instruction, like in it?
You mean as like the overflow? Yeah. I guess we could. Yeah. So then I can say registers. Well, then we would only have mul lit and mul reg.
Yeah.
We could do that. However, I think we might also. Now we've got a little bit of a dilemma, because the way they do it is with just having multiply by something, and then we just say REX equals REX times that. But we can just do multiply one thing by the other, and we'll just have like, for example, mul REX RBX will be REX equals REX times RBX, but we can also do it the other way around. Which one of the two do we want? What do you guys think? Should we just stick to the way that they do it? We probably should.
I don't think anything. My brain is empty.
If at any point you have any questions about what I'm doing, please just tell me, because...
Yeah, sure.
Yeah. I think after this I'm actually gonna implement printf. Yeah, sure. So I can now say registers.eax equals to register.eax times literal, and this will be mul lit, and this will be mul reg, and this will just be like this, and then I can say times this equals this times. And the
multiply by a memory address, right? Like a value at the memory address. So mul mem.
We could do that, however, I don't think that's really necessary as,
Can always.
yeah,
move
we
it
could just
into
move
the-
mem into reg. I think like you cannot. I don't think you can actually do that in R assembly either, where you can just say move a or multiply by a memory address, and you just have to move the memory into a register and then multiply by it. I think that's
Oh
like
yeah, right.
yeah. I think that's more logical, anyways. So in the instructions, I'll change this to mul reg. Oh, mul reg and mul lit. Okay, and now we'll do, let's say function calls. Or, yeah, let's just do, have a separate region for this. We can have like as many, like our address space isn't very big, but with 255 different addresses, or, like things for for instructions, or instruction space, I mean, I don't think it's too bad.
How are you gonna do the screen, by the way?
Honestly, I'm not sure yet. For the screen itself, I'm gonna have memory mapped I/O, which I'll get into in a bit. But I'm not sure if I can implement just straight up the same format strings in Java as I can in Python. If I can, that would be absolutely great, and I'll see if it works. But we'll tackle that when we get there. So there we have final static public byte call equals 0x 0x30. We're of course not going to be able to load any external libraries for now, so we're also not going to have like libc or anything like that. So I'm thinking either we have call and then a value after that, and we define the value after that inside of our CPU.java, or we just have an instruction for call underscore printf and call underscore scanf. I think that might be the best way to do this.
Isn't it just call and then address?
An address?
And then, like at that address, the function.
Yeah, but then we'd have to manually include our printf functions. I honestly, like, it would be a great idea, but I honestly cannot be bothered. So I'm just gonna make my printf and scanf inside of Java, instead of like inside of the actual machine code.
But at some point you have to do subroutines anyway.
Yeah, we're gonna make the logic for subroutines, and we're gonna even make it a little bit better than the way that they do it. However, like if we do it like this, then we'd have to spend like a lot of bytes. First of all, on our case of implementing printf on our own, and that's like already an assignment in assembly. So I'm not gonna do that in my own assembly. But second of all, we would have to use like a lot of bytes of our already limited like only 0xFF things, especially if you want to include more functions than just printf and scanf.
Yeah.
So I'm just gonna have like one thing called call printf and call scanf, and then like maybe call exit. It's not the most elegant solution, I'm gonna be honest, but I think it's like the best solution for now. So now we can have a call. And I'm honestly just thinking of seeing if there is a printf function in Java. And just using that.
There is a system.out.printf, but I'm not sure it supports all the things the cprintf does.
Yeah, true.
Yeah, it supports a lot less.
Yeah. What about java.format? Because we use .format up here as well, right?
String.format should I think it does the same as the normal printf.
That would be absolutely sick. So it would be a Java sprintf. That makes sense. Oh. Okay. This seems alright. It seems like it's doing everything we want it to. However, it's gonna be... I might just say that... How are we gonna do strings? That's my question. Because strings are like a very abstract concept in assembly, because everything else is just numbers, and strings is like something above that.
Just do them zero terminated.
Yeah, we can do them the same way as that, but then like in our printf function we would have this address.
The address
instead of the thing.
Entry of the array.
Yeah, then we have to like say have like a scan till null function where it scans till it's 0 byte.
And even the fact that you're gonna print a string there as well. That's probably the most annoying part.
Oh yeah, this depends.
You would end up just re-implementing printf at that point.
Yeah. I think I'm just gonna do this, but instead of allowing strings, I'm just straight up not gonna allow strings. Let's see. So instead of all this stuff, we're gonna make it a little easier. So we're gonna have a calling convention, and it's literally gonna be exactly the same as the other one. So we can call printf. But then we need a format string as well.
Oh, you're gonna need a string anyway. Fuck.
Yeah.
Well, that might actually be easier.
Yeah, let's just do it like that. So we've called printf, and it has a few things. We have our string or our format string equals registers dot. Or let's say format string memory location. What a fucking name. That will be a long equals registers dot
mem address.
EDI. It's never used. Shut up. And I because this is our printf. Like we can inherently say whatever we want during this thing. So we can also just define for ourselves that you have to have a format string. So for example, if you want to just print a string, you gotta binnen. Lecture that's over. All right. I'm streaming by the way, so. You okay? Shit. Yeah. Lecture is just finished. I watched the entire lecture online, like the other one, you know. Yeah. Thing. And honestly. Didn't miss jack shit. Alright, sick guys. Everybody is here and not there, you didn't miss anything. Well, I mean, you missed a few things.
Nice.
There are multiple types of fucking systems. You have stuff that does memory to memory, you have stuff that does register to register, you have stuff that uses accumulator. Oh, I'm sorry. You mean our instruction set. And fucking... Or the fact that we either used an accumulator or not that we made in this thing. We're doing this lecture ourselves. This lecture is our bitch. I still recommend, you know. Here. No, but wait. Are you talking about the ISA one or the? ISA. Oh yeah. The one you missed nothing. Okay, no. Okay, guys. The tutorial you missed nothing. Yeah. Okay. So for the tutorial of the last self-assessment, you didn't miss jack shit. I already could tell you that. For the rest, what we are doing now encompasses the entire thing. I would watch it, but this is gonna help a lot. Like, of course, there's still gonna be things that are not in there, but it is gonna help a lot at least.
Okay, nice.
Yeah, so that's gaming.
For like a minute or 5, or like at max.
I'm like currently like recording and streaming and everything. I've got like 20 people here, so I'd rather not. Okay, so let's implement printf, guys. Fun stuff. So we've got a format string memory location. So I can say first byte equals to char first byte equals to fetch. So we're gonna have a first, like the first byte, which will just be the fetch of the memory location. Does this work though? Oh, because it's a memory location, it's gotta be an int, but that means I explicitly gotta cast this to an int. Oh. Why does this not work? Int. Okay, so we've got the memory location of our string is loaded into EDI, and then we're gonna take the first byte, which is this thing, and then we can look until while first byte is not equal to 0, or I guess in this case we can just say character byte, and we can say this is a byte. We'll use byte representation anyway. So while first byte or a character byte isn't 0, this is an issue.
First convert
Like
it
memory
to a
location
string and
plus
then
8.
Yeah. So this
first
should be.
convert it to a string and then use dot format to put parameters in.
Yeah, but we. Wait, I could say string.
I mean, is it plus plus or plus 8? Plus plus or plus 8? How do you count?
Well, our memory is byte indexed, so that means
Okay.
that this is fine. So while char byte is not 0, or I guess I would have to do like this then.
Yeah.
Or yeah, if I just say.
Wait, no. If
character-
it's a byte, I think 0 for a byte is just plain zeros.
Yeah. Okay. Let's keep it as byte. I wasn't decided at that yet, but let's keep it at just byte. So until then, we can say char byte equals to oh yeah, and then I don't need this conversion anyways. Char byte is this. So then we say okay, it's the next one, and then we can say format string plus is char byte.
This skips the first character.
Yeah, you need to put it.
Yeah, that's a good
The
point.
char byte has to be put on the end.
You need to get the new char byte at the end. So you first do things and then you get new char byte.
Oh yeah, that's actually a really good one, because then I don't have to. Because then the. Oh.
Yeah, you can leave it there. Mhm.
Yeah, that's actually really smart. Yeah, I do that. Okay. Typo in word memory location. Shut up. I can type. Let's see. So I think this should work now. So if I now call, let's see, format string.sout. Okay, now we're gonna have to implement this. And the annoying thing is, we do not have, we cannot just use label. We cannot just say, like, I don't know, my string ASCII 0 lol. We cannot do that. However, what we can do is we can say, okay, we will use an instruction called mov literal to register. The register is going to be contain the address of our string. So we got to put our string at like some location inside of our memory bank. And this is like already getting quite complex, by the way. So if you don't understand it, just ask me. I can say, okay, the address we're going to use is 0x 2000. We can use that, right? Yeah, I think so. Into RDX. So here I can say move that into registers.edi. I mean. Okay, So now we have the move literal to register, and we move the literal 2000 into EDI. That's good. Okay. But what we can now do is we can say I equals 2000. And we can say my CPU.memory I++. And now we can construct our string character for character.
And what is your
can
format
handle
string type?
string now.
Because there you do format string plus equals char bytes in the function.
Yeah?
So what is the string? Okay, never mind. Yeah.
Okay, cool. So now I can say, is there like a way to get a character from... Can I say like bytes and then a character?
Yeah, maybe you can do like char add.
No, you would have to create a char and cast it to a byte, I think.
Yeah, it might be.
So
Oh wait,
just
I'm dumb. This is not the syntax. So if I do... Oh.
Yeah, and that char there can go as well. Sure,
This
that's
works.
cool.
That's really sick. That's like actually really sick. So I can say HELLO. I never said it would be quick. I just said it would be sick. Space WORLD
Maybe, I don't know.
exclamation mark and then a 0 byte. That's gonna be like this. So now if I print the memory location at starting at 2000, or actually we gotta be careful here. This is 0x2000. And then we do like 15 bytes, and then we don't step yet. I'm just curious as to what would be in EDI and stuff. So let's see if this works. Oh, HALLO space WORLD exclamation mark 0 byte. Nice. Oh yeah. We gotta step once before we can actually see what is in EDI, because moving it into EDI is actually a step. And this seems correct as well, because if we go here, we say hex this, that is 0x2000. Okay, so now I think we're actually ready to call our printf. So I can say my CPU dot memory I++ equals to instructions dot call printf. And keep in mind, everything our printf does for now is just print our format string. That's not how it's gonna be, but it's how it is now. No, that's call. Oh yeah, step. Okay, so now, yeah, that helps. Oh, I think that is because in our printf we are... Oh yeah, this is still a byte. Of course, I'm a dumbass. That means I convert this to a character, because now it's just adding like the raw values of the byte. So now it should print. Hey! Our hello world function works! Thank you. Okay, but this is not yet how we want it. Because this is only the format string.
Yeah.
So now we need to count the amount of percentages that is in there. And also you're not going to be able to print the percentage sign for our string. I'm not going to include that because I honestly to God cannot be asked. But is there a way to count occurrences in string Java?
I think you can use the .contains method.
Yeah, but the thing is, we don't want to know if it contains it, but we want to know how many times it contains it. Because we want to have, like, for example, if it's like 4, then we need to pass 4 parameters. Or
Is there an index?
I think we might even be good, anyways. Because if we just, I'm gonna check this real quick. If I can say string.format with this,
You can use the index.
You can give it
of
more
that-
than it needs.
yeah, like if I just do
Nothing fine
this,
with that.
I'll get like 4 things, but it will not use that, and it should not. Yeah. Oh, that's great. Because that means that we can just pass all the arguments to our printf function regardless. Hell, I think we can even do like printf here. Or is that the same or not?
I think it is.
Yeah, I think I saw somewhere that printf is same as string.format print.
Yeah,
but
it works.
it doesn't
Okay.
include the headline. So
Okay, but now if we make our string hello space percentage u, that means that it should also.
That's not
yeah.
char anymore.
I was about to say that's not a char. Percentage u, then that should mean that it should take a percentage u here, which will take the first argument, namely 1. Conversion is u. It doesn't know u. Okay, let's say what happens if I do d. And if this doesn't work, I'm gonna be really concerned. Hello, 1-year-old. Oh, that's sick because 1 is the thing here. Okay, so now let's see. What is the calling convention? Let me put that up here real quick. Calling convention RDI, RSI, RDX, RCX. These are the 4 values we're going to be using for our calling convention. So that means that we can just say our first var arg. I'll use that real quick. Will be registers registers dot esi.
This will limit it to 4 arguments.
Yeah, totally. That is correct, and frankly, that's all our user is gonna have. If you want more, just print another string. Lol. Var arg2, var arg3. So ESI, EDI, ESI, EDX, and ECX. So now I can just pass along here as arguments var arg1, var arg2. I forgot semicolons. For arg3.
You're missing EDA. Oh, never mind.
Okay. So this is real good. Now it's time to figure out what we can do with this. Because this is like... Yeah, this is cool. So, now I can say, instead of our value being this, I can say, let's do a double... Oh, yeah,
That's not
a double... Or, in this case, just double word, which is an integer, I think. Let's do a hexadecimal number, or a character, and I think this is hexadecimal number.
yeah, I believe so.
Yeah, lowercase has hexadecimal.
Okay, that's cool. So we've got an instruction move literal to register, so I'm just going to copy that a few times.
Just for the people that are interested, are now starting in like a minute.
Oh yeah, that is a good point.
Yeah, I'm gonna keep it on the side.
Yeah, I am not that good at RNL.
I think we're going to discuss induction again, and I already know all that shit from high school, so...
The thing is, I don't. So I think I'm gonna end my stream for here for now. And we'll continue after RNL. Is that okay with you guys?
Yep, so
Sure.
fine.
Alright.
Thank you
Okay.
for your demonstration.
Yeah, I'm really glad. This is really fun. I like you guys' input.
Yeah, we're having fun.
Okay, well, I'll see you guys again after RNL.
Yeah.
Have a good one.
Yep.